Fat cells, or adipocytes, are another important cell type in loose connective tissue. Isolated fat cells, or small clusters, are mixed in various proportions in many connective tissues. In protected places, especially pure adipose tissue can often be found, filling crevices and niches. This image is an example. Some mesenchymal cells apparently differentiate before birth into pre-adipocytes, which are programmed to become fat cells, or adipocytes, at a later time. Given an adequate diet and hormone environment, they first start accumulating fat in numerous small droplets. Eventually, these coalesce into one big drop, which pushes aside the nucleus and the cytoplasm. Conventional techniques of slide preparation use organic solvents, so that the fat droplet is almost invariably lost in histological preparations. One sees only a huge empty hole where the fat droplet was outlined, with a narrow red band of cytoplasm. Their appearance has given them the name of signet ring cells. You see nuclei in only a small percentage of them. This is because the nucleus occupies only a small region, and most cells get sectioned in many ways that miss the structure. A curious feature which you can't see here is that each fat cell has its own basal lamina. Yes, some connective tissue cells have a basal lamina in addition to epithelia, whereas many others don't. For instance, fibroblasts, macrophages, and mast cells. Also, the cells in adipose tissue are supported mainly by reticular fibres, again invisible to the light microscope without special staining. Fat cells constitute a metabolic reserve for the body. Starvation can lead to a real loss of fat and an apparent loss of fat cells. However, the depleted fat cells have only reverted to the appearance of fibroblasts. The propensity of these committed cells to reacquire fat still persists. Adipose tissue is richly vascularized with capillaries, small arterioles, and venules. But wait for my lecture on the cardiovascular system before trying to distinguish one type of blood vessel from another. The important point at this time is that adipocytes and adipose tissue are metabolically active and not just inert storage depots. Fat tissue is not always well preserved on histological slides. It's easy to allow the delicate rims of cytoplasm of fat cells to partially collapse after the fat has been extracted. And in this image, you can see the way fat cells often look in routine sections. Compare the routine observation you are most likely to see when examining tissue sections to the way they appear in this connective tissue spread. Fat cells dominate the spread, but all you see is the thin rim of cell cytoplasm with the occasional profile of a nucleus. But they each just look like one big fat droplet. In addition to ordinary unilocular fat cells you've just seen, there is another variety called brown fat. It gets its name from the colour of fresh tissue due to its rich content of mitochondria. Instead of having a single droplet of lipid, brown fat cells are multilocular. The stained cells have a sponge-like appearance. The collection of tiny fat droplets has much more surface area than one single droplet of ordinary fat cells, and this allows a much higher rate of metabolism. The main function of brown fat tissue is to produce heat, and this tissue is especially prominent in animals that hibernate. Adult humans don't have brown fat, but babies do, around the shoulders and the back. The example here is from a monkey.